afternoon, class. Welcome back. We are on our online theory. We are on chapter 10, part 3. That is the physiology and histology of the skin. So go ahead and open up your books so that you can follow along. So what we're going to do first is do a brief review of our last session of what we learned so that we can connect it to what we're going to learn today. We talked extensively about the dermal layer of the skin, which is the second layer of the dermis. We talked about the reticulary layer and all of its components. There's the hair follicle. We went over all of the parts of the hair follicle. We talked about the sweat gland known as the sudoriferous gland and how there are two types of sweat glands, the apocrine and the eccrine. We reviewed the sebaceous gland that produces the sebum or the oil that lays on top of the epidermis. We also covered the acid mantle extensively and how our skin gets its pH of 4.5 to 5.5. I believe in your textbook it refers to 5.5 through the combination of the sebaceous gland and the sudoriferous gland. We talked about the pH scale and understanding the purpose of the pH scale in skin. So review your notes on those because that is really important in skincare and picking the right products and also knowing what procedures to do on your client's skin. We reviewed the 4 grades of acne. And from 1 to 4, we reviewed the different types of lesions that are on acne skin, and we went into those as well in detail. Some of the conditions that acne produces, we also reviewed, and then we had an assignment, and your assignment was to complete the vocabulary list as well as to work on your chapter outlines. So I know most of you got that done and turned it in and stapled it to your gold sheet. So now we're ready to go over our next part of the same chapter 10. We're on part 3. This particular part of your chapter is going to talk about the skin cells, and as we move up into the epidermis or the top layers of skin. The skin cells themselves have a lifespan of anywhere from 28 to 45 days. Now, we've reviewed the diagram already, and at the bottom of the epidermis is where the life called the stratum germinativum layer is where the life of the skin cell begins. So if you're young, which means 35 and below, then your skin cell is going to take about 28 days from birth until it's actually exfoliated off of the skin. If you're mature skin, which is 35 plus, it's going to take longer. So the older you get, the longer that natural exfoliation process will take place. Okay, so the objective of healthy looking skin is to keep the skin exfoliated. Again, when you're younger, you don't have to worry about it. It does it on its own. When you get to be 35 plus, now's the time that you're recommending enzymatic peels, you're recommending chemical peels, microdermabrasion, different types of products and modalities that are going to keep the skin exfoliated so it doesn't have that buildup use. The skin cells are made of protein. And when protein breaks down on the links, it makes the amino acid. Once again, the protein is called keratin, and keratin is made up of your carbon, oxygen, hydrogen, nitrogen, and sulfate. And they also have phosphate as well. The kera, K-E-R-A, refers to the protein of keratin. Keratinocytes or corneocytes are both cells of the protein of the dead skin cells. So you're going to hear me refer to keratinocytes, or you're going to hear me refer to keratinization. All of those mean the buildup of those dead skin cells that have keratinized because the skin cell has died and now it's almost like a translucent color. It's filled with the protein of keratin. You're also going to hear a new word, desquamation. Desquamation refers to the actual exfoliation of the skin. It's just another term that refers to exfoliation. In the professional world or in a clinical office, they would use the word desquamation. Okay, so let's move up into the epidermis. A little bit of information before I go to the board on the epidermis. The epidermis is thinner than the dermis. When you are aging, then there's a change. So let's take a look at how it's going to look on the skin. When you're young, you have a large dermis or a thick dermis, and you have a very thin epidermis. Can anybody tell me why they think that would be? Why do you think when you're younger, 35 and under, that your epidermis is thinner and your dermis is thicker? Think about it for a half a second, okay? Now, if you remember in our review of the dermis layer, we talked about the dermis layer being referred to as the ocean. A lot of that activity takes place is natural. It's just producing and producing and producing. There's an abundance of water, there's an abundance of collagen, there's an abundance of hyaluronic acid. So our body is producing it. Well, it's got to go somewhere, so it stays in the dermis, and that's what makes the dermis thicker. At the same time, when you're younger, your skin is naturally exfoliating. You don't have to think about it. Remember the 28-day cycle we talked about just a few minutes ago? And here is the new baby skin cell, and it takes 28 days for it to come to the top and to exfoliate off. Okay, so now as we age, everything begins to slow down. It's called the natural aging process. It's going to happen to all of us, okay? In the natural aging process, we begin to lose moisture. We begin to lose hyaluronic acid. Everything begins to slow down. Our fibroblasts are not producing as much collagen. So there's not a lot of plumpness and the ocean is depleting. So as we age, the ocean gets thinner and the epidermis gets thicker. So what used to take 28 days here is now going to take 45 days. So as you age, the epidermis gets thinner and the epidermis gets thicker and the dermis gets thinner. Okay? So I hope everybody understands that, because that's a major part of knowing what type of exfoliation the client's going to need. If there's a thick dermis or epidermis, what do we need to do? So make sure that you go over that in your book as well. All right. So now we're going to talk about the epidermis as a whole. So let's go ahead and look at the skin in your textbook. Go ahead and look at the diagram. Okay, so everything moves from the bottom up. So we're going to start with the bottom, okay? So this is our dermis. We already talked about our dermis. We talked about the reticulary dermis, and we also talked about the papillary dermis. The papillary dermis is the thinner part that's on top, and the reticulary dermis is on the bottom. All right? So now we're ready to look into our first layer. This layer is called the stratum germinativum. Kind of a long word, okay? Now, in this layer is known as the reproductive layer. Means this is where the baby skin cells are born, this is where they're fed, this is where they're nourished. They fall into a single file. So if you ever look at the diagram, you'll see these layers of baby skin cells. So let's talk about these baby skin cells for a second. If you know this, if you have a female and she's pregnant and she has a nightlife, she smokes, she drinks, she doesn't live healthy, she doesn't sleep, she doesn't take care of her body, she just has an awful lifestyle, and she's pregnant. When she delivers the baby, she's the host, so when she delivers the baby, what are the odds that that baby is going to be healthy? Not very good. Okay, so now let's take that same scenario, and we are the host of our skin cells. Okay, so these are our baby skin cells. If I eat right, if I watch what I put on my skin, if I wear a sunblock, if I'm using correct products, if I take care of my skin, my body, my health, my lifestyle, then my skin is generally, almost always, going to be healthy. Those skin cells are going to be healthy. They're going to be full of nourishment and full of water. But if I don't, if I smoke, if I indulge in all the free radicals as alcohol, fried foods, if I sunbathe, if I stay out late every night, I don't sleep, then my skin cells, me being the host, are going to die right after they're born because they didn't have a good start in life. So the objective is to take 28 days for these cells to get to the top layer. When the host is unhealthy, that's not going to happen. What's going to happen is these skin cells are going to die somewhere over here, and they're going to start laying flat, and that's where you get that dull appearance. That's where you need that deeper exfoliation, because you got to get rid of the dead skin cells. And sometimes they can be deep into the skin. So the client has to agree that when she gets a peel that she wants to take care of her skin. She has to agree that she's going to use the right product. She's got to agree that she's going to wear a sunblock. She has to agree that she's going to stay out of the sun, drink plenty of water, lay off the cigarettes. And to be honest, a lot of clients don't want to make that commitment. It's like starting a diet. We all go in it with good intention, but after the third day, it's kind of like you begin to start to slip away. So just know that when you have to do exfoliation, it depends on where, at what layer are those skin cells dying, okay? So the baby skin cells are supposed to grow and reproduce. In this particular layer, the stratum corneum layer, it is referred to as the reproductive layer because those skin cells are multiplying by the process of mitosis. And mitosis is when one cell turns into two daughter cells, okay? In this layer, you also have your melanocyte cells. These are the cells that produce pigment. And we're going to talk a little bit about those in a minute, okay? Now, the object is to keep the baby skin cells hydrated and fed nourishment for as long as you possibly can. They are eventually going to die, and they are eventually going to exfoliate off. But you don't want it to happen down here. You want it to happen way up here. The more that it takes, the higher that they get, the more healthy the skin is going to look. It's going to have a rosy tone to it. It's going to have a plumpness to it. You're going to have a diminished amount of fine lines. So making sure that the skin is fed is what our serums are for, what those Hydra-D masks are for. Keeping the skin exfoliated is what our enzymes and our peels are for. All right? So now let's talk a little bit about the melanocyte cell. The melanocyte cell produces the melanin, or the pigment coloring of the skin. Okay? Now, I'm just going to give you a simple rendition of how this works. So, inside the melanocyte cell, you have two enzymes. And these enzymes are called the tyrosine enzymes. Okay? When these two enzymes are stimulated, they touch. They move around and they touch. Okay? I call it they kiss. When they touch, they produce pigment or pigment cells. So the object here is so that when we are suntanning on purpose and we want to get some color, we want an even color, we generally use a lighter sunblock. The UV rays will stimulate the tyrosine enzymes to touch. And then when you're younger, you get a nice even tan. When you're older and you go into the sun, it's not nice and even anymore. Now it's blotchy. The reason it's blotchy is because some of those tyrosine enzymes has died off. And so you don't have an even tone color. Now, if you look at skin from Fitzpatrick's 1 to 6, we have a variation of color. And it's how the activity of those melanocyte cells that give us color. In other words, somebody that is Caucasian skin and somebody that is African American, they both have basically the same number of melanocyte cells in the stratum, dermatium layer. The difference is the activity layer of production is more active in the Fitzpatrick 6 than it is in the Fitzpatrick 1. Therefore, if you have a Fitzpatrick 1 Caucasian skin and she goes out to the beach and she's out there for a half an hour, because the stimulation or the activity of her tyrosine of the enzymes is slow, she's going to burn. It's going to take a while for those tyrosine to touch to produce more pigment. When that pigment is produced, it's a line of defense so the skin doesn't burn. That's why most Caucasian skin will go to the tanning booth first, and they will get their underlay of stimulation through the UV rays of a tanning booth so that it starts the process. So when they go to the beach, they don't have to burn. They've already stimulated this activity to take place so that they can have a nice golden tan when they go to the beach. On the other hand, if it's Fitzpatrick 6, they do as well get sunburned, but you don't see it. Their activity level of producing pigment is quick. It's every second. So they're constantly producing the pigment, which is what gives them their darker color. That darker color is a first line of defense after the unbroken skin. So it protects us from burning, it protects us from the UV rays, It protects us from the pigmentation. Okay, so it's important that we understand how melanocytes work so that when we are doing a chemical peel for pigmentation, we know that which peel to use, but we also understand the importance of wearing sun protection. Okay, so does anybody have any questions? If you do, make sure that you email them in and we'll get them answered for you. Okay, now there are two types of melanin that are produced in the body. Remember, melanin is the pigment. It is controlled by the DNA or your genetic makeup. The first type is called pheomelanin. That has a red-yellow pigment to it. And the second type is called eomelanin, which has the brown-black pigment. So the brown-black pigment is generally going to be in your Fitzpatrick's 4, 5, and 6, and the pheomelanin is generally going to be in your Fitzpatrick's 1, 2, and 3. Okay? Now, when we look at how do we control pigment, or how do we eliminate pigmentation on the skin that's in clusters, be it from sun or from hormones or from trauma to the skin like post-inflammatory hyperpigmentation, we have to look at what's called triosinate inhibitors. And so these are the triosin enzymes. So how do we get them to stop? Well, we use triosinate inhibitors. And there's a couple of them on the market that are used a lot in skincare that help to retard the production of the melatonin. The first one that's mostly popular is hydroquinone. Hydroquinone has had its debut with the FDA. They use it a lot in the doctor's offices because it's pretty aggressive. Right now, I believe it's on the market at 2%. 4% it's a drug, and some physicians also recommend 8% of the hydroquinone. And what that does is it's a chemical that goes in and blocks up the triosinate enzymes so that they don't touch. The problem with that is that because it is a chemical, if you put that on Fitzpatrick's 4, 5, and 6, then you're going to have the challenge of repigmenting because the chemical is going to be too aggressive. In other countries like Europe and Asia, it's against the law to use hydroquinone. So once again, it's great for Fitzpatrick's 1, 2, and 3, but when you get into the 4, 5s, and 6 Fitzpatrick's, it can repigment. So you want to be very cautious about when you use that. We also have kojic acid. And kojic acid's been used for some time now. Kojic acid is rice fermentation. It's a type of acid that's used in skincare preparations to help to slow down or stop the triosinate enzymes from touching in the production of pigment. So it's a natural acid as well. We also have azelaic acid. Azelaic acid comes from wheat, rye, or even barley. With azelaic acid, most physicians recommend 20% hydroquinone, 4% hydroquinone mixed with 20% of your azelaic acid, and that gives a perfect formula for pigmentation. Once again, be careful with that hydroquinone. All right. When we use azelaic acid, sometimes you'll find it in preparations that are mixed with your vitamin A. And the vitamin A preparation is wonderful because you'll not only get the pigment that will lift, but once it lifts, the vitamin A acts as a keratolytic. And a keratolytic means that it creates the shedding effect. So it will not only lift the pigmentation, but it'll also eliminate it from the surface of the skin. So vitamin A is a great keratolytic to be mixed with azelaic acid for the reduction of pigmentation in the skin. It's also good for acne scarring, which shows up as brown spots on the skin for your Fitzpatrick's 4, 5, and 6. Another ingredient that's used extensively, and it's one of my favorite ones, is arbutin. Arbutin comes from bearberry, which is a natural extract. It's derived from the bearberry plant. It's safer on the cells, so it doesn't have that aggressive approach the way hydroquinone does. It's less toxic. It's great. It's a great alternative to the hydroquinone for those that cannot use the hydroquinone. Used in an 8% concentration, it works beautifully on all skin types and skin colors. We also use licorice root. Licorice root has been used for some time now. It's safe on the skin, and it's wonderful for lifting up post-inflammatory hyperpigmentation. It is in 20% concentration, works beautifully on Fitzpatrick's 4, 5, and 6 as well. Mulberry is a root bark from the mulberry tree. Safe, and it has a lower concentration, so you're not going to get the quick effect with it, but you'll get the long-term effect. Mandelic acid has hit the market probably about 5-7 years ago, and they use it a lot for the pigmentation in the skin. It is a chemical, and it helps to reduce the dermal melasma. And dermal melasma is pigmentation that has gone down into the dermis layer. And that's a little bit more difficult to remove since most of the pigmentation is above the epidermal junction. When you have dermal melasma, it's generally going to show up on the surface of the skin as real light pigmentation. When you have epidermal pigmentation, it's going to show up darker on the skin. And believe me, the darker pigmentation is going to be easier to remove than the light pigmentation. Because the light pigmentation, you can hardly see it because it's so far down into the skin. The mandelic acid is pretty gentle on the skin, so the different percentages and its combinations will work well on most Fitzpatricks. And then we have the vitamin A or the retinol. Usually you'll find vitamin A in the triosynate inhibitor combinations because vitamin A is the perfect keratolytic. It's a non-chemical, so it mixes well with your other natural ingredients. It will help to create the cell turnover. So if you've lifted pigmentation or you've retarded pigmentation, sometimes it'll get darker before it exfoliates off. It'll look like little coffee grounds. Having vitamin A in the preparation or in the product will help it come off quicker without having to see that layer of dark skin. So we've talked a little bit about the triosine enzymes, and we talked a little bit about the triosynate inhibitors. Depending on the product line that you're using, follow the manufacturer's directions. You as an esthetician can use all of the natural inhibitors, but when you get into the hydroquinones, you can only recommend up to 2%. Anything over 2% is recommended by the physician. If you're using any kind of triosynate inhibitors, you must wear a sunblock of at least an SPF of 30. There is no declining that. It has to be done. If you start using triosynate inhibitors, which are actively working on the enzyme, and you don't wear a sunblock, you're going to look worse than when you began. So make sure that your client knows that that is part of the treatment. Okay, so if there's any questions on that, please make sure that you email them or ask me when you're in class. Okay? Alrighty. One other cell that's found in the Stratium germinativum layer is called the Merkel cell. That's a sensory nerve cell. It's a sense of touch, and it's generally right on that same line. And it's a cell that we don't have a lot to do with, but it's there, and so we have to mention that. Okay? So any questions, once again, make sure that you email them. We're going to move up now to the next layer in the skin. So let me get rid of this. So this was our germinative layer. And so now we're going to move up one more layer, and that layer is called the Spinosum. Now, I like to refer to this layer as the holding tank. Okay? What that means is that once this gets full of baby skin cells, it has to push up, because remember, everything in the epidermis moves upwards. So it has to push up, and it pushes up into this holding tank or this holding cell until the skin cell has matured. So it'll stay there for just a little bit, maybe a week, a couple of days to a week, just until the cell has matured and gets pushed up as well. These cells now are changing in shape. Instead of being nice and round and fat and solid, they're beginning to change the shape, because the further that they go up, the further away they are from the ocean, which is the water. So they're beginning to change, and they grow these prickly spines on them. These prickly spines are what is the protein links to the cell. They're creating oils and proteins in this stage, and they're creating the desmosomes. And that's that little, between a cell, let me just show you. Here's a cell, and here's a cell. So in order for those cells to hold together, you have this little prickly spine, and that is called the desmosomes. It holds the cells together, and it gives the skin its strength. That's wonderful when you're young. But as we age, these desmosomes sometimes build up, and they don't let the dead skin cells exfoliate off. So for a longer period of time, you're holding on to dead skin cells. Okay? One more cell that we have in the Spinosum layer is our Langerhans cell. The Langerhans cell is the immune cell of the skin. So this, if you scratch your skin and you get an infection, it's the Langerhans cells that come to the rescue. And those are found in the Spinosum layer. So let's stop there for a few minutes, review your notes, and we'll be back. Okay, welcome back, guys. Get your soda, get your water. Hope you're relaxed and ready to write. Okay, so now our next layer that we're going to move up into is our granulosum layer. Personally, I think this is the most important layer to the esthetician when it comes to exfoliation, and I'll explain why. Okay, so let's get rid of this. And now we have the granulosum layer. Okay, the granulosum layer is about 2, maybe 3 weeks into the 28-day cycle, 2.5 weeks, let's say. So now the cell is so far away from the ocean that it is beginning to dehydrate. It's beginning to die, okay? Think about it this way. Let's say that you're at the ocean and you're on the shoreline barefooted. You're standing in the sand. What does that sand feel like between your toes? It's still kind of granular, but it's wet and moist. If you took 20 steps backwards where there is no water, what does that sand feel like? It's dry, brittle, hard, and scratchy. Okay? So now that's where we're at. Here's the shoreline to the ocean, and this sand here is full of moisture. Okay? As we move up through the layers and get further away from the ocean, the dermis layer, we have less moisture floating around in the skin, and the skin cells begin to die off. They begin to lose their nucleus, and they begin to die off. Their moisture is gone. So they take on this granular layer. If you, as an esthetician, as a professional, can understand the granulosum layer, you will never have a need to exfoliate beyond that layer. This is the layer we want to target. For no reason that I can think of do we ever, as an esthetician, need to erase the layers of skin that are still alive and that are still full of moisture, unless the host has such a bad lifestyle that those skin cells are dead, okay? For instance, a chronic smoker, a chronic alcoholic. All right, I give it. You may want to peel a little bit deeper. But in general, your limit should be to the granulosum layer. If I can target the granulosum layer and exfoliate those dead skin cells, it only makes room for these baby skin cells that are healthy and still have moisture and they still have life to them to move up quicker, so my skin would be rosier, it would be healthier, it would be more intact. I wouldn't have a pigmentation issue, so it would look really, really hydrated. It would look healthy. So once again, the granulosum layer, the cell begins to die, it begins to create keratin, which is the protein. It takes on a granular shape, hence the name, the stratum granulosum layer. It's the most important layer to the esthetician, because if you could exfoliate down to that layer, then you're allowing the healthy cells to come up to the surface. You're purposely going to create necrosis or the death of the cell for that exfoliation to take place. If we are using enzymes, then the enzymes we have been taught generally work on the horny layer of the skin. But if we're using enzymatic peels, then we have an enzyme that is encompassed with a chemical acid. And therefore, I'm going to get the best benefits of working on the surface as well as the penetration. And these enzymatic peels are not going to penetrate so aggressively that they're going to burn the skin as if it was a straight chemical. And generally, most of them will reach the granulosum layer where that exfoliation is needed the most. We do have what's called the natural moisturizing factor, and that is to waterproof the skin so that the moisture that is brought up with these cells doesn't evaporate out of the skin. And that natural moisturizing factor is sealed in by the top layer of the acid mantle. So when we're doing corrective skincare, we have to know at what layer is the skin condition. So therefore we can decide, do we need an enzyme, do we need an acid, and if we are using an acid, how far does it need to penetrate? What kind of trauma do we need to create to the skin, if any? All right? So the granulosum layer, as we go through skincare and this course, you're going to understand a little bit more about the granulosum as we indulge into chemical peels and exfoliation. So for right now, just know that it's the granulosum layer, it's dying, it lacks moisture, and it's taken on a new shape. And it's the most important layer to the esthetician when you're doing corrective skincare. All right? So we're going to move up one more layer on the skin. And this is our stratum lucidum layer. This layer in the most textbooks is considered only found on the palms of the hands and the soles of the feet. In your textbook, it reads a little bit different, so always follow what your textbook says. But know that if a question on the state board says which layer is found only in the palms of the hands and the soles of the feet, it would be the lucidum layer. It is a clear layer of skin cells. Therefore, there is no pigment in these cells. And light passes through these cells that are keratinized. This gives us our fingerprints and our footprints. So if you ever see an individual that's a Fitzpatrick 4, 5, or 6, meaning that they have darker skin, you look at the palms of their hands or the soles of the feet and they look white. And that's because of the lucidum layer. The Caucasians 1, 2, and 3 Fitzpatrick also has it. It's just not as noticeable. So for the purpose of this textbook and this class, know that the lucidum layer is on the palms of the hands and the soles of the feet. Okay? So now we're moving up to our top layer of the epidermis, known as the stratum corneum layer. Stratum corneum layer. This is the first layer of the epidermis. So we started at the bottom, which the 5th layer was the germinativium, then the 4th layer was the spinosum, the 3rd layer is the granulosum, the 2nd layer was the luciderm, and so the 1st layer is the stratum corneum layer. The objective of this layer is to keep it exfoliated, to keep the dead skin cells off. And in order to do that, we have to have the proper products to do that when the person or the individual client is over 35 years of age. Remember, under 35 years of age, they've got their own natural exfoliation taking place. This layer is thinner than the dermis because it has less water. We do have some natural moisturizing factors taking place. The skin cell here is a little bit flatter, and you can see it lays like bricks. And they're held together by a motor, which is like a glue, called desmosomes. Remember, we talked about those just a little bit earlier. And the desmosomes is the glue that holds the dead skin cells together, okay? As we age, if those desmosomes aren't broken down naturally, then the skin is holding on to dead skin cells and it looks gray, it looks a little unhealthy, it doesn't have any life to it. Your job as an esthetician is to be able to go in, break up the desmosomes, and allow for exfoliation to take place. As soon as you exfoliate these top layers, new skin cells are pushed up rapidly. When that happens, then collagen is produced, and everything else falls into place like the domino effect. And then you have healthy looking skin. Again, this layer is waterproof because of the acid mantle, and it is regenerated by cell turnover. Our objective is to keep those dead skin cells off. And the more that we keep them off and the more exfoliation that we have, whether it's natural or induced, then the healthier the skin is going to look. We need to keep that skin detoxified and free from infection. The sweat secretion and the oil secretion create the acid mantle on top of this layer. All right, so this layer produces the corneal site cohesion. Corneal site cohesion is when dead skin cells are stuck together and they can't exfoliate off. And that's when you need to go in with either an enzyme combination of an enzyme and a chemical peel to make that happen. All right? So the brick and mortar, the brick is the dead skin cell. There's very little water in there. And the mortar, the glue, is your desmosomes. So again, you need enzymes and acids for penetration to make this speed up the process of exfoliation. All right? Now, that brings us to the outer epidermis. The outer epidermis, that's the skin we touch and feel every day. The outer epidermis is referred to as the horny layer. In medical terms, the horny layer means to desquamate or to shed, to exfoliate. And this horny layer is what is held together the dead skin cells by the acid mantle or the combination of the oil and the sweat. It's important to know that there are about 20 to 25 layers of those dead skin cells, and if we do not have a natural exfoliation process, they build up really, really quickly. So our first line of body defense is our horny layer, and it creates our acid mantle. So we have natural desquamation from the horny layer, but at 35 plus, we need help. So that's where products come into play, and that's where treatments come into play. Our lifespan of the skin cells at this point is anywhere about 45 days, depending on the health of the client and the products that they're using. These skin cells are flat. They're laying on the skin, on the top of the horny layer flat. So for instance, if you were to scratch your hand, you would see like little white flakes fall off. That is the horny layer. Those are the dead skin cells. All right? So now we have covered the dermis and the epidermis. At this point, I want you to refer to your textbook, review the section of the dermis and the epidermis, review your notes, and play this video again in case you have any questions. If you do, go ahead and email them to us, or you can ask in class when we return. Thank you and have a good day.